Hello, in this video we will talk about skewness in statistics. So skewness is a measure in the statistics for the distribution of the data. And if skewness is positive, so the data has a longer tail on the right side in the distribution. And if the skewness is negative, it has a longer tail on the left side in the data distribution. And in the mathematical form, it is the dimensionless version of the third moment about the mean. So first we will see this figure. So in the middle, it is a symmetrical distribution. So this data has a skew 0. And in this form, mean, median, and the mode of the data has the same value on the same vertical line. And for the left figure, this plot has a longer tail on the right side. And this is called positive skew. So in this distribution of the data, the mean is located here. And median about this place, and the mode, which is the highest frequency of the data on this vertical line. So mean is larger than the median in positive skew. And this item represents the negative skew, which has a longer tail on the left side. On the lower value side has a longer tail. So here the mean is lower than the median and lower than the mode. So in the mathematical form for the skew, it is about the third moments of the data. Third moments is the data, each observation minus its mean value, then take cubic in the power. Then we sum together divided by n. So this is called third moment is m3. So because this is a cubic in the data for the difference from the mean. So this is m3. And we also have an item called s3, which is actually the cubic of the standard error. So here S is the sample standard error. So we show you this S square is the sample variance, and then take a square root. So is sample standard error. Then take the cubic in the power. So this is S3. Then the skewness called gamma equals M3 divided by S3. So this is a dimensionless scale. So this item is larger than 0 is a positive skew. Less than 0 is negative skew. And 0 is no skew. Is the symmetrical data. So it's quite easy, right? So next we show an example for the data. So we go to a program, R programming, R Studio. So we set the working directory and we load the data. So we show very simple data, this data. This data has only one variable called values and has 30 observations. So in our form, it is a data frame. And one variable, one column with 30 observations. So to make it easier we just attach this data. Then we create a function called skew. So in the function, we set M3, S3. M3 is the sum of each observation minus the mean of this data. Then take the cubic, then divided by the length of S. So this is the n sample size. And S3 is the square root of the variance of data, then take cubic. Then M3 divided by S3 is the return value for this function. And it is the result of the skewness. So before we calculate the skew, we can show the data. So this is the histogram of the skew of this data. As you can see, it is quite clear that the right side of the tail is longer than the left side. So it is possible that this has a positive skew. So next we can run the skew. So actually it is 1.3189. So it is quite significant for this skew of the data. And if you want to make hypothesis testing of the skew, so hypothesis testing, which means we will set a null hypothesis. So this null hypothesis is that the data has no skew, or the skewness is 0. We just set a null hypothesis that the data is symmetrical. And based on this null hypothesis, we can calculate a statistic. So this statistic is the skew. This skew is same as we calculate. This is a point value, right? Because if we make different samples, may comes with different skew. So this is the point value of the skew we calculated before. Then divided by the square root of 6 divided by n. N is the sample size here. So this statistic follows a t-distribution with n minus 2 degrees of freedom. So this is same to say that if this value is connected with a very lower p-value, so we will reject this null hypothesis that the data comes from a no skew distribution, right? So this is statistic. If very, very large, very, very small negative value, absolute value is very large, very small, so we can calculate this p-value. So to calculate the p-value of the t-distribution, so we can use 1 minus pt. So pt function in R programming is for right side of the cumulative probability. Because in the distribution, if we look at this figure, for example, if you want to calculate these distributions, these critical values, p-value. So for example, this is 2.90 like this. So in the R calculation, a pt function will calculate the cumulative distribution from the left side to this value. So the p-value actually is 1 minus this left side's area. So p-value is on the right side, a very small area, small probability. And in this example, because calculation of this value is 2.949, so we can use 1 minus pt of this value with 28 degrees of freedom. So actually this p-value is very low, very significant, lower than 0.05. So this will come with the same conclusion that we see this skewness is 1.3, right? Very large. So this is highly significant for positive skewness. And in this example, we write a function for calculating the skew from the ground off. But you can also use some library in R, for example, E10, E71. Just load this library, but you have to install this first. Then you can directly use skewness function from this package. I will show this value. 1.38 is quite close to what we have calculated with the function we write by ourselves. And you can also use another package called moments in R to calculate the skewness of this data. So we get the very similar, actually the same for these two packages. So, and why it is so important to know the skewness of the data? Because in many statistical modeling or application, you have to use the symmetrical data, or at least normally distributed data in the dependent variable, right? At least for the dependent variable, the data have to be not very skewed. Not like this, not like this on the very long tail on one side. So if we have very confident proof that the data has positive or negative skew, so sometimes we may make some transformation of the data. For example, take a log of the data or some non-linear transformation for the data to make it look as symmetrical. So this is the idea connected with the skewness. So thanks for watching.